Okay, so we're on 3A.3 compound interest. This is how we are applying our knowledge of exponents in just general application of math in real world situations. Okay, so 3A.3 compound interest. This is our compound interest formula. Our compound interest formula has a lot of variables in it. We have 5 variables. A is your balance after the time has passed. P is your original amount invested, your original starting value. R is your interest rate in decimal form. N is your number of times per year interest is compounded. And T is the number of years interest is compounded. Okay. The key thing here is that it's in terms of years. Okay. So if I give you 36 months, you would tell me how many years. 3. I was hoping we all would be good there, right? 3 years. 3 years equals 36 months, right? So you wouldn't use 36, you would use 3. Make sense? All right. So we're going to first start off with example number 1. And with example number 1, we're going to go through, we're going to read it, and we're going to go through and identify our variables. Cool? So up first, we have the amount of 500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? Okay. So going through our variables, first we're going to start with A. Well, we currently do not know A, right? We don't know A. Our P, our principal, our initial amount. What was our initial? 500. What's our next variable we need? Our R. What is our R? It's 9.5%, which equals 0.095. Agree? Okay. Compounded monthly. So compounded monthly, how many months are there in a year? 12. So that means N equals 12. And lastly, it wants us to know the balance of the account after 3 years. So our T equals 3. I have identified all my variables. So what am I going to do now? We're going to plug it in. We're plugging into the formula. A equals P times 1 plus R divided by N to the N times T. Okay, so we're going to plug everything in. A, we do not know. Our P is 500. 1 plus our R divided by our N to our N times our T. All variables have been plugged in. So what is left for me to do? Simplify, calculate, right? So I'm going to go to a calculator. And I'm going to type it in. So we have 500 times 1 plus 0.095 divided by 12. I'm going to hit Shift 6. Yes. Yes. Mm-hmm. Okay. And you could if you wanted to beforehand, or if you're putting it to the calculator, do you really need to do any simplifying? You don't. The calculator is going to do it all for you anyway, right? Okay. Yes. So after 3 years, how much would I have in my account? And 14 cents. So we have $664.14. Are you guys ready to try on your own? Sure. I believe in you. You got this. Okay. Y'all are going to do example 2. I want you to quietly try it completely by yourself and then check with a peer. Okay. Open your computer. We're using Desmos. Yeah, I just modeled it for you, girl. Okay. So you're doing example 2. Each year, so that means your N in this case is going to be what? 1. It's going to be 1. And it says each year, not each month, right? Yeah, the T, right?
I think this is completely wrong. I put the equation in, but that one was like.
Anyone need anything? Are we okay?
230.
It's one time. Then it says yearly, so your N is
Well, I guess it's not.
Yep. Perfect. Hey guys. You're looking at your increase, that's coming from your 2.3. So it's about how much an increase. So all right, so here we go. I see hear a lot of talking, see a lot of smiles, so that means we understood it, and we're gonna go. All right. So for this problem, we were specifically looking for our A. What was my P? 150. My R? Perfect. My N? And my T? 6. Good job. From 1994 to 1988, the best year ever, to 1994. Because I was born. Oh. Why was it best year ever? You second guessed me. It's money. So money, we can have cents, right? All right. So when you plugged all that in, what do we get? 231.50 cents, right? That 49, that 8, whatever made that 49. Yes. All right. Now, example 3 is going to be a little different because this time they're telling us our A and we have to find our P. I'm just prefacing what we're going into, okay? Oh, all right. It says, how much would you deposit in an account that pays 6.25% interest, compounded semi-annually, to have a balance of $5,000 in 15 years? So this time we know our A. What's our goal? 5,000, right? Oh. We don't know our P. What is our R? There we go. What is our N? 2. Perfect. And then our T is 15. All right. So we have all of our variables identified. We're going to plug it into our formula. So now we have 5,000 equals, we do not know our P, 1 plus 0.0625 divided by 2 to the 2 times 15. Okay. So all that I can evaluate first is this, right? So this is all that I can plug in and evaluate to find that first. Okay, so we're going to find the value of this. We're going to simplify this piece, right? So after we simplify, what do we get? P times what? Let's go look. So we have 5, what was it? 1 plus 0.0625 divided by 2. I press shift 6. And it was 2 times 15, right? All right, we're going to round to the nearest 3 decimal places and try to stay as accurate as possible. So we are at 2 and 517,000. Agree? All right. Yes. All right, so we're at 2 and 517,000. This is just now basic math. What do I do to find P? We're going to divide. So P equals 5,000 divided by 2 and 517 thousandths, which is going to give us approximately so we have 5,000 divided by 2 and 517 thousandths. And we get approximately 1,986 and 49 cents. Yes. So if I want my goal to be 5,000, my initial investment has to be at least $1,986.49. Yes. We have to have $1,986.49. Yeah. All right. So are we okay with finding P? Yep. All right. Here we go. What if the value is decreasing? How does that change our formula? We're subtracting. That's the only thing that changed, right? Everything else is still the same. So with that little bit of knowledge at your table, you're going to do example number 4 and then check with each other. Got it? Okay. So the change here is what again? Decreasing means we are subtracting. All right, go. For a year means what again for N? 1. Yes. All right. Your chapter, we're good. All right, so this situation is actually modeled after a true story. My PT Cruiser that I bought. So I bought my PT. Obviously, it was a gold, like it was perfect. I love my PT Cruiser. I got it. It was the best looking. It was the best looking PT Cruiser. Got it at a really good price. And 3 years after having it, almost paid off, by the way. I got hit by a passenger van. And so my car was totaled. Yeah, you know, PT Cruiser versus a 15 passenger van. Guess who lost? Luckily I walked away with just a little bruise, but yeah, so when they take your car, do all that, they're like, oh, your car is only worth blah 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 amount. And what did y'all get was the value of my car at the end. That was roughly the value that they said it would be if it was in perfect condition. But it wasn't perfect condition because it got hit by a car, right? So I actually didn't get that amount for it. I only got like 3,200. See, all right. So that's the story behind this problem is why this amount was chosen. All right. I realized that I can use my sad and tragic life. His name was Sonic. He was electric blue, turbo engine, golden. Sunroof, leather seats, It was awesome. All right, so we plugged it all in. So we had our A equal 12,500. 1, but we're decreasing, so it was minus. Oh, you got a minus. Make sure you pay attention to that. To the power of 3. Yes? How much did Sonic value out after 3 years? 6,400 if it hadn't been smushed. But yeah, easy peasy. All right, so I promise you 10 minutes to work on your assignment. You should have 10 minutes to work on your assignment. Yes? All right. My challenge for you is only ask your peers for help if it's an odd problem. Otherwise, I want you to try and do it independently.